This video takes a new look at the measurement problem, which is the measurement problem of quantum mechanics, which is really about what goes on inside that black box that we can't get to, of interactions producing the results of experiments, particularly quantum mechanical experiments like the Stern-Gerlach beam splitter, where Bob and Alice head off forever in opposite directions, are sent conjugate pair particles from the beam splitter, have their little dials which can rotate their fields, and they get this very strange set of results which we haven't been able to rationalise physically. We could use quantum mechanics, which gives a very good mathematical reproduction and prediction, so we tend to settle for that, but we have no physical analogue, no satisfactory mechanism of how it can be produced, because it implies non-locality, that Bob can change Alice's setting just by changing his 1 billion miles away, which is, frankly, we're suggesting here, wrong. It's a false assumption stemming from an initial false assumption. Niels Bohr is very careful to try not to make any assumptions, but that was a problem in itself because he didn't hypothesize what may be going on inside our black box of measurement interactions. So here we consider the polarizer of Bob and Alice's detectors, which is the initial polarization screen which the signal hits before it's transmitted to the orthogonal channel photomultipliers or photodiodes, normally a 2-channel setup, to produce the output which we then analyse statistically to produce quantum mechanical predictions. Works fine mathematically, but we haven't got a clue how it works. Well, quantum mechanics says it's weird. There is no physical way it can work. So here we're looking at, we hypothesize that the electron field that makes up the polarizer, and indeed the photomultiplier, it's really all measurement is interaction with initially free electrons on the surface of a lens or shocks around astrophysical bodies. So we're looking at this spinning globe before us as one of those electrons. They're all identical. If Bob or Alice reverse their field, they all reverse. They can flip them, turn their dial 360 degrees, they go all the way around back to where they started from, spin one. So if they change them 90 degrees, then the interaction result will differ. So the electron is, and the meter is, as von Neumann and Bohr said, part of the system, an important part of the system, because light, for instance, has no memory of prior states, which Anton Zeilinger established. After its polarization, repolarization, with electron interaction, it has no clue what its previous polarization was. It has a different one. All elliptical, all polarization is elliptical to some extent. We talk of linear and circular polarization. But all signals from interactions, and electrons have the strongest coupling coefficients with electromagnetic energy. All polarization resulting from interactions has some ellipticity. It's either that way or that way, any direction we like. Maybe it propagates as a helix. We know light is helical from optical sciences. But it's an ellipticized helix. We also know that electrons, free electrons, may be Majorana fermions, which are their own antiparticle, form the surfaces last scattered of Scott and Smoot's Nobel work throughout the cosmos, peculiar velocities. Light interacts with surfaces, which give it different polarizations. So, when light interacts with an electron, it's controlled by, or the resulting re-emission is controlled largely by the electron, which is a lot more powerful partner of that relationship. So we're now hypothesizing that this rotating sphere is going to absorb, because we're not talking about cannonballs here, we're talking about motions and absorption and re-emission. It's going to absorb the energy at some interaction tangent point on the surface and re-emit it in the same direction, because the refractive index of plasma, free electron plasma, is n equals 1. It doesn't refract, so ergo we can't really tell it's there except kinetically, which gives us kinetic reverse refraction. But that's another matter. So we're looking at an electron picking up a signal from where? From the beam splitter, okay? From the Stern-Gerlach experiment beam splitter, which sends conjugate pairs, which are thought of as opposite states, but with maybe both states superposed, and they collapse to 1 on meeting Bob analysis detector. Well, let's have a close look. Let's imagine for a moment that this spinning sphere is going to be split and sent off in 2 halves in opposite directions. So whatever form we imagine, it might be 2 smaller spheres, or let's just say it's sliced in half. It still has both polarizations. The planet Earth has a North Pole and a South Pole. The North Pole rotates anti-clockwise, looking down, orthogonal to the surface. Whereas doing the same with the South Pole, it's rotating clockwise. So we have both plus and minus charge or rotation on all single spheres. They are all dipoles, which is after all an analogy of the Majorana fermion, which is its own antiparticle. It can also be looked at as twin vortices, toroids, but we're keeping it simple here for the moment. So our conjugate pairs go off in different directions to the beam splitters. They may go off 1 billion miles and arrive at Bob analysis detectors, where they have their dials. They can preset their dials. They don't collude with each other. They just set whatever they fancy. They can do it at the last second. We've done experiments to prove that just instantaneous changes in their dials, well out of range, communication range with each other, appears to change the other's result, finding, outcome. But that's from statistical analysis, and you all know about statistics. That's based on an assumption which was forced on the originators of quantum mechanics, Niels Bohr and Heisenberg, by there not being a classical analogue for the findings. They had to assume quantum spin as a weird non-physical type of spin, because they had one momentum, very simple, but they had this orthogonal one, which was quite different and did different things, and it was very difficult. Niels Bohr tried not to make any assumptions, but of course was forced into assumptions. If you don't hypothesize, then you make hidden assumptions, really. Well, Niels Bohr wasn't really familiar with the Poincare sphere, which is quite equivalent to the Maxwell equations with curl and linear momenta. And this sphere has two completely different sets of momenta. It has curl, which is at the equator, which is maximum at the equator, clockwise or anti-clockwise, at 180 degrees, but zero at the equator, maximum at the poles, zero at the equator, minimum or rather minus maximum at the other pole. So -1 to 0 to +1, changing over 90 degrees, disappearing. There's no clockwise or anti-clockwise momentum if you touch a sphere at the equator. You can't tell. You have maximum uncertainty. And then inverse over 180 degrees. That's the rotation. Now there's another one. It's not really hidden, because of course the equator does have a momentum. It's either left or right. The opposite, again, at 180 degrees. It's round the back. It's going a different way to round the front. If we flip it, they'll both be flipped. So we've got linear momentum there. That's heading left or right, or if we're at 90 degrees, it'll be up or down. And then that is maximum at the equator. That reduces to 0 at the poles. So it's reducing inversely to the curl momentum, and then goes to maximum minus value at 180 degrees. So we have two completely different, separable momenta on the surface of a sphere at any radius. So through coloured, right the way through. Size doesn't matter. So it applies to absorption as well as billiard balls bouncing off. Now, that's quite new, really, except that if we study the spin statistics theorem, mathematics, and the findings, it's actually implicit within there. We just haven't really derived a physical source of that yet. Now, what's also interesting about those two orthogonal, opposing, offset, inverse momenta is that their change over across 90 degrees is non-linear. It actually changes at a rate by the cosine of the angle, and it's the angle of latitude on a sphere. So from 0 to 90 degrees is a change from 1 to 0, and then over the other 90 degrees in the other hemisphere it also changes by the inverse amount, also by the cosine of the angle. And linear does the same, because in fact we've got an analogue here with the speed of rotation of any point on the surface of Earth, which we know from geophysics is the cosine of the angle of latitude. Speed of rotation is very low, and in fact at the poles it's 0. There's no speed at all, there's just a curl. There's a rotation which hasn't got a speed, it's just a rate in RPM. So these two qualities are measured differently. So the changes across the surface of the sphere are by cos theta latitude. Now this will start to become familiar to those familiar with quantum mechanics, who know the basic magical little formulation and relationship with Malus's law, an ancient Egyptian finding from light experiments, of cos theta. And in fact, the quantum mechanical derivation cos squared theta, which is a weird one. That's what we have never found any physical possible analog for, or mechanical derivation of. Now, when we look at the system, at the measurement system, we have, of course, two parts. We have the polarizing screen, which we've been thinking about. These electrons here are the polarizer. The initial signal comes in with some polarity of its own, but the electron is the dominating force because that's more powerful for each individual wave or photon that arrives with it. At any orientation, it will send out a different signal. As Zeelinger's finding, it won't matter much what the incoming signal polarity was. It will have a different polarity with no memory of its previous polarity sent over to the photomultiplier, which then gives us our clicks from each orthogonal channel. There are click rates, which then gives us our quantum mechanical predictions. So let's just consider polarity. The polarity we get from this. All polarities are elliptical. So polarities are ellipticized by interactions. We talk about linear and circular polarity. There's no such thing really, except in special cases. It's all elliptical to some extent. So the signal that comes out from here, we have major and minor axes on the ellipse. We can actually, because it's translating through space, it explains really why light is helical, as the optical sciences very well know. Light has helicity, and it's chiral helicity. It's either one corkscrew or the other, and that will depend on which way up the electron is. So the ellipticized helical path signal being sent out then arrives at the photomultiplier, photodiode. And one of those channels will receive the major axis amplitude and thus produce a click. One of them will only receive the minor axis amplitude, which, when properly tuned, will not produce a click. So we will only at any time get one click from one of those channels, mostly. When polarity is almost circular, we may find, and depending on the tuning, that both channels will click, or that neither channel will click. But generally speaking, we only get clicks from one of the channels. So we have the ellipse, which may be on any orientation, which depends on the orientation of our polarizer field electrons. And that then is, it influences or dictates the click rates from the photomultiplier, which is what we then analyse between Bob and Alice. So Bob and Alice reverse their own finding. There's no need for Bob's switching his field, rotating or flipping his electrons, to affect Alice a billion miles away instantly. There is no non-locality required. This is a classical mechanistic sequence which produces quantum mechanical output, which is exactly as John Bell predicted. Now, the cos squared theta, the magical Dirac equation formulation, comes from the second electron interaction at the photomultiplier, because all measurement is exactly the same. We have fine structure electrons on the surface of all lenses and at every astrophysical shock in George Smoot's Surfaces Last Scattered out in space. So the second interaction changes the sine curve, and in fact the Dirac equations offset sine curves 90 degrees offset, so as one's going down the other's going up, one measurement that way. It's not position and momentum. There are two momenta which we're measuring, both with maximum uncertainty at 90 degrees. But the second interaction at the photomultiplier then changes that sine curve to cos squared theta, the square of the cosine value that's emitted from the first interaction, then has another set of interactions with the electrons at the photomultiplier, and we get the click rates at the square of the cosine of the angle, because the photomultiplier rotates with the polarizer field. The whole system will rotate. This can easily be checked by setting up different Stern-Gerlach and detector experiments. Now, we've measured this with a digital tachometer, and I produce it in an FQXI essay. The results showing rotation with this rubber tip is 0 there, it just skids. But as we go round there, we suddenly start to get rotation, and then we have maximum rotation at the poles. It's, and of course, reversed over 180 degrees. It's probably easier because this is also works with light, so we can measure it as we change the angle of latitude. We pick up the momentum, so we get maximum rotation at the poles, going to 0, where we get maximum linear motion, and then reversing at the other pole. So it doesn't matter where we are on this sphere, we have a mixture of rotational and linear motions, changing inversely by the cosine of the angle of latitude on the sphere. Now, this is a hypothesis, but it's testable, and it's also, by the very fact that it works, really it has proven veracity, because we've never found any physical interaction process which can reproduce quantum mechanics. There's no requirement for quantum spin. We have our two momenta. There's no requirement for non-locality. Bob changing his setting doesn't affect Alice's. There are a number of other quantum effects which can be reproduced, but we won't go into it now because I think what you've just seen is quite enough to take in one go. You'll probably need to watch this video 3 times over to memorize it. But it does reproduce, and I showed this in the FQXI essay in 2018. We showed the graph of the momenta which it produces with the change of angle across the surface, and the physical process fully reproduces quantum mechanical predictions. Interestingly, it will also allow unification with special relativity. Because in 1952, it's been ignored, but Einstein derived a spaces in motion within spaces with boundaries concept. Now, with these surfaces last scattered made up from these electrons, what the implication from that is that the re-emitted signal from the electrons is not only polarized by the field electrons, but its re-emission speed is dictated by the electrons. It is C in the frame, in the centre of mass frame or centre of rotation frame of the electron, of each electron. Now, of course, the electrons in a field are relatively stable in relation to each other, so a full electron field will then convert the speed of light in one reference frame incoming to the speed of light with respect to the matter it meets, which is in motion in relation to the emitter and the approach field. So that then allows, as Einstein suggested in 1952, Appendix 5 to the 15th edition of Relativity, his book, that SR is implemented by that new arrangement and it's compatible with quantum mechanics. Slightly shocking and revolutionary, but it is testable, and I beseech anybody to test it.